Okay, Algebra 2 kids, we are going to start in Chapter 8. Now, this is Section 8.2, as you can tell. I'm skipping 8.1 because everyone that's in Algebra 2 is either currently in geometry or has already had geometry, and it's about distance and midpoint, and we know that. That's been kind of beaten into us over and over again by this point. So I'm moving on to 8.2. We are talking about conic sections in this whole chapter 8. And parabolas is this section 8.2. We've already talked about parabolas when we talked about solving quadratic equations. That's the graph of a quadratic equation is a parabola. But we're going to actually define it a little differently and talk about kind of why it is the shape it is. Okay, so this is the study guide. I'm actually going to back up a page. I added a page of notes here for this video. And again, it'll be included in the notes with the link below the video and in the Algebra 2 classroom folder. So you can access this. These are snippets from our textbook. Okay, I just used the snipping tool and took a picture and moved them in here. So we're going to talk about kind of where parabolas come from. And if I'd had a little more time, I would also tell you, you might want to Google a parabola GIF. There's some nice GIFs or GIFs, however you pronounce it, that kind of show these things being made or being drawn or created, and they're pretty slick. But let me just start reading this and then we'll talk about it. It says, you know that the graph of y equals a times x squared is a parabola. Again, quadratic equation is when we have an x squared that opens up or down with the vertex 0, 0. Now we know it has a vertex 0, 0 because again, we don't have any b or c terms in our quadratic. And the axis of symmetry, remember your axis of symmetry is, the line with which it's symmetric if you folded the board on it. And the axis of symmetry is x equals 0. Remember, that's a vertical line. On any parabola, each point is equidistant from a point called the focus and a line called the directrix. Now, this is kind of the new definition of a parabola. Why does a parabola have the shape it does? Well, this point here is called your focus. I hope you can see me kind of like make that bigger. This point here is your vertex of your parabola. And this line right here, this blue line, okay, I'm going to put it dashed, that is your directrix. Now, what you can see here is they've kind of visually drawn two line segments, and they're telling you that these two line segments are congruent. Again, from geometry, they each have these 3 dashes in them, right? These are congruent. Every point on a parabola is equidistant from the focus, that's a point inside kind of the bowl of the parabola, if you will, and the line that is the directrix. Okay, every point on a parabola is equidistant from the focus and the directrix. And remember, when you calculate the distance from a point to a line, it's got to be measured perpendicularly. Okay, remember that. But again, any point on that parabola is equidistant. So of course, they've got these marked with 2 dashes. Okay, equidistant. Any point is going to be equidistant. Also, notice they have these marked equidistant. This, as you can see, is your axis of symmetry. Okay, I usually draw it as a dashed line. This is your axis of symmetry. Your axis of symmetry will always be perpendicular to your directrix. Okay, for us, one's going to be vertical, one's going to be horizontal every time. And then your parabola, of course, is your solid blue shape. Now, if you see here, some of the some better definitions. It says the focus lies on the axis of symmetry. The vertex lies halfway between the focus and the directrix. Again, you can see that because they have it marked congruent. Okay. And then it says the directrix is perpendicular to the axis of symmetry. Now, it says the equation of a parabola. Up until now, all the ones that we've done are parabolas that open up or down. Okay. Now we're also going to talk about the possibility of them opening left or right as well. So first of all, it says the equation of a parabola that opens up or down and has vertex 0, 0 can also be written in the form x squared equals 4py. This is kind of the new form, if you will, of a parabola. Okay. Parabolas can open left or right as well, in which case the equation has the form y squared equals 4px. So the direction the parabola opens depends on which variable is squared. The x squared is going to open up or down. The y is squared, it's going to open left or right. And then the p, notice in the formula it says 4py. If the term in front of the single variable, the one that's not squared, is negative, then it points down or left. If the term or the number in front of the single term is positive, it points up or right, okay, depending on which one we're dealing with. So once again, let me kind of circle here. This is a picture, obviously, of your basic parabola. You've got x squared equals 4py, okay? P is greater than 0. Now, notice the coordinates of your focus are 0p. Notice your directrix equation is y equals negative p. Okay, your vertex is at 0, 0. Remember, this is congruent to this. They're p away from each other. Okay. Now, if it opens down, okay, what this is saying is that p has to be less than 0. Then you're going to have a like an x squared equals negative 4y or something. Okay. And again, focus, same thing as 0p. Your p is just going to end up being negative. Your directrix is y equals negative p, which is actually going to give you y equals a positive value then. Okay. And then again, your parabola is pointing down. Now, parabolas pointing left and right. Okay, I'll try to leave just enough of the other ones up there. Parabolas pointing left and right. These are the ones that have y squared. And of course, I've got a couple of those dead spots on the board. Y squared equals 4px. Okay, if p is greater than 0, it points to the right. Again, your focus now, instead of being 0, comma p, it's p, comma 0. Because your focus is now going to be on your x-axis. Okay, and your directrix, notice the equation of your directrix changed. Instead of being y equal a constant, it's now x equal a constant because it's a vertical line. This directrix obviously is vertical. Okay, and again, I want to point out that this distance is p and it is congruent to this distance that is p. Those distances from the directrix to the vertex and from the vertex to the focus are p, length, okay? And if your p is less than 0, again, it's going to point left, which is negative on the x-axis, so that makes sense. Okay, left and down are negatives, right and up are positives. So same kind of deal. Again, just pointing out your focus is on the x-axis, so it's p, comma 0. Your directrix is a vertical line, so it's x equals negative p. Okay, so you have to kind of, when you look at it, you have to be able to tell, okay, is this a left or right parabola or is this an up and down parabola? Okay, now last thing that I snipped out of your book here that I thought was important, key concepts for your notebook. Standard equation of a parabola with vertex at the origin. Okay. Standard form of the equation of a parabola with vertex 0, 0 is as follows. Okay, this right here, let me just point out, if you have an x squared, it's an up or down parabola. Okay? If you have a y squared, it is a left or right parabola. My sad little parabolas there leave a lot to be desired, but that's okay. So if x squared, up or down parabola, y squared, left or right parabola, and it just depends on whether p is positive or negative. Okay, your focus is either 0p or p0, depending on whether you have an up or down or a left or right parabola, and your directrix is the opposite of p. Okay. All right. Now let's go back to the study guide here. So the vocab here is on any parabola, each point is equidistant from a point called the focus and a line called the directrix. That sounds great, good, and fine, but that's why I added the page of notes from your book, because I think until you get some more definitions in there, it's kind of hard to see. So now we have x equals 1/4 y squared. It says graph that, identify the focus, directrix, and axis of symmetry. I think this one's worth stepping through here. So first of all, first thing they did, you'll notice, is solved it for y squared. Now, y squared, the first thing that jumps out at me, this is either going to be a left or right parabola. Okay? And actually, as I look at this, since this is positive, it's going to be a right parabola. Okay? So that's the first thing. Again, I'm a picture person, so I like to kind of visualize it in my mind, and then it helps me do whatever work I need to do. So step 2, identify the focus, directrix, and axis of symmetry. Obviously, we know on all of these, for right now, our vertex is going to be the origin, 0, 0. Okay? Now, if our basic form of a parabola is y squared equals 4px, then obviously we have 4x equals 4p. No, sorry, I should just say 4. Well, I'll do 4x equals 4px. So 4 equals 4p, so p equals 1. Now, what does that tell me? That tells me that my focus is 1, 0 right here. Okay, that's my focus. And then my directrix, remember your directrix is x equals negative p or x equals negative 1. That's your directrix. Because y is squared, the axis of symmetry is the x-axis. Obviously, you can tell that. Okay, this is your axis of symmetry, right? Okay. And then draw the parabola by making a table of values. I just plug in some points. Again, we know 0, 0 is one of them. I usually try to find, like fairly normal ones. These are a little different because the y is squared. So notice, if they're making their table of values, they've got plus or minus on either side. This is the one that I would have obviously easily seen. Notice they're counting by 2's in the graph. So if you put in a 4 for x, you're going to get a 4 for y. So again, then you have your graph. Okay? So sometimes I kind of graph these by flip-flopping my x and y's a little bit, and I make y like my independent variable because I think it's a little easier to see, but we'll do some of those. Okay? Now here, they give us the picture, we have to write the equation. So the first thing we need to write an equation is p. Okay, so right off the bat from the picture, I see that my directrix is y equals 1/2. So remember, your directrix is y equals negative p. So that makes your p negative 1/2. Okay? That's the first thing that would jump out at me. We substitute negative 1/2 for p. So, and again, they set up here negative p is positive 1/2, so positive p is negative 1/2. Okay? Again, that means that this right here would be your focus. Your focus, if they graphed it, would have been a 0, -1/2. Your focus has always got your P in it. Your directrix is the opposite of P, or -P. So then here's your basic equation, basic form of a parabola that points up or down. Remember, the up or down ones are x squared. The left or right ones are y squared. And then we plug in the -1/2 in place of P, and that's my equation. It really is quite simple once you kind of get the hang of it. So let's look at the back page. Okay, graph the equation, identify the focus, directrix, and axis of symmetry of the parabola. Now, I have actually added another page to these notes so that we've got some decent graph to work with. So let me go on to the next page. So we have x squared equals 1/4 y. Okay, so I'm going to put that here. X squared equals 1/4 y. That's what we're graphing. Now, right off the bat, the thing that jumps out at me is because the x is squared, it's going to be an up or down. Okay, the other thing that jumps out at me is that the number in front of the y is positive, so that means it's going to be up. Okay, so this is going to be a point up parabola. Okay, so I know my vertex, I can at least start there. I know my vertex is going to be 0, 0. Now, I need to know focus and I need to know directrix. Okay, then I can plug in some points. But focus, since I know it's up, I'm going to do some of my work down here below since I know it's pointing up. So remember, your basic form is x squared equals 4py. So that means then that 4p has to equal 1/4. So p is 1/16. Holy smokes. Okay. That means that your focus is going to be 0, 1/16. That's going to be a little hard to graph. Literally right above the vertex. And your directrix, okay, is going to be, now that's going to be a horizontal line, okay? So that is going to be y equals -1/16. Okay? So here's your focus. I should have probably written it in red. Okay? Your directrix, again, is literally right below it. It's 1/16. Obviously, it's kind of hard to see here. -1/16. And then your axis of symmetry, obviously is just the y-axis, or the line x equals 0. Okay, that's your axis of symmetry. Now, we've got to plot the points. Okay, so let's solve this. This is actually y equals 4x squared. You all see that if I multiply both sides by 4? That's kind of how we're used to seeing it. So then if I make a table of points, okay, and I know that since this is a parabola, I'm really only going to do some positive numbers because their mirror image are going to be the negative x with that. So obviously I've got 0, 0. If I plug in a 1, I've got 4. If I plug in a 2, I'm going to get 16. This is a really, really skinny parabola. So 0, 0 is my first point. 1, 4, my next point. 2, 16 would be way up here. Okay, so this is a super skinny parabola. All right, that's why the directrix and the focus are so close to the vertex. Okay. I hope that helped. Now, number 2, I'm not going to toggle back because I know what it is. Number 2, our equation is y squared equals negative 2x. Okay, y squared equals negative 2x. Well, we know if it's y squared, that means it's a left or right parabola. Okay, left or right parabola. Actually, let me put these in blocks so we know what our original equation was. Left or right parabolas, again, we're looking for the number in front of the single term to know whether it's going left or right. So since it's a negative 2x, it's going to be facing left. This is going to be a left parabola. Okay, I know that just by looking at the equation. The y is squared and the number on the other side in front of x is negative. So I know it's going to be facing left. Now, we need to solve and get our p. So remember, our basic equation is y squared equals 4px. So that means that 4p equals negative 2. So p is negative 1/2. Now, what that means is that is going to be my focus. So my focus is going to be negative 1/2, comma 0. Now, notice the difference. Your focus over here, on the first one we did, the x coordinate was 0, and your p point was in the y coordinate spot. Here they're flip-flopped because it's a left and right, well, in this case just left, facing parabola. So negative 1/2, 0 is your focus. That also means then that your directrix is going to be a vertical line, okay? And that's going to be x equals positive 1/2. Okay, remember it's the opposite sign of the focus. So that means that this right here, I can't seem to draw a straight line, but you get the idea, is my directrix. Okay, my axis of symmetry is obviously going to be my x-axis, or y equals 0, whatever you want to say. Okay, and then we got to plot some points. So I know that my vertex is 0, 0. Now here's how I usually kind of plot these points. So if I have y squared equals negative 2x, that is negative 1/2 y squared equals x, right? If I divide both sides by a negative 2. So if I'm making a table of points here, I'm actually going to kind of do it backwards. So I know I've got the point 0, 0. If I put in a 1 for y, this is where I'm kind of flip-flopping the independent, dependent variables here. If I put in a 1 for y, I just get a negative 1/2 for x. Okay. If I put in a 2 for y, 2 squared is 4. 4 divided by 2 is 2. I get a negative 2 for x. If I put in a 4 for y, 4 squared is 16. Divided by 2 is 8, but I've got the negative. So negative 8. Okay, so I kind of do it kind of backwards. So 0, 0, and then I've got the point negative 1/2, 1. So this, whoa, I have no idea what just happened. So right here, and I'm going to have its counterpoint, negative 2, 2, and I'm going to have its counterpoint, and negative 8, 1, 2, 3, 4, 5, 6, 7, 8, 4. So this is going to be my parabola. Now, you don't have to plot a ton of points, but something that you can kind of see. Okay, notice it's a lot wider. The other one, even though I graphed it on the same kind of chart, again, the p was 1/16, so that made it a very, very skinny. Okay, let's keep going. The next one's here. Number 3 was, here's the equation we started with. It was x equals 1/2 y squared. Okay, well, let's solve that for the squared variable. Okay, so that gives us, let me write it this way, y squared equals 2x. Okay, I hope you guys see that. So I'm like multiplying both sides by 2, and then I just flip-flop the sides. So y squared equals 2x. Again, because the y is squared, this is going to be a left or right parabola. And because the number in front of the x is positive, this is going to be a right-facing parabola. Okay? Now, very similar to the one we just did that was y squared equals negative 2x. Okay? This one is positive 2x. So essentially, everything's just flipping signs from the previous one we did. Okay, so once again, y squared equals, well, let me do this way. Let me do it on this side since I know it's facing to the right. So y squared equals 4px is our basic equation, right? So that means that 4p equals 2, so p is 1/2. So again, I'm not going to spend a lot of time redoing this. We did it on the one above. But my focus now, my p is positive 1/2, so my focus is going to be positive 1/2, 0. That's my focus. Okay. My directrix then is negative p. So my directrix, and again, it's a vertical line, is x equals negative 1/2. So again, that's my directrix. Okay. Now, here's my vertex. Okay. Oh, one thing I forgot was the axis. Same type of deal. The axis here is the x-axis. Again, that's x-axis of symmetry, or the line y equals 0. Okay, remember your axis of symmetry and your directrix are always perpendicular. And then I'm just going to kind of use the same type of points that I had on the one above. If you all remember, let me see if I can scroll up and get some of those. Instead of the x's being negative, they're going to be positive. So 1/2, 1. And again, it's counterpoint. 2, 2. And 8, 4. So this would be my parabola. Okay. All right, last one for the graphing. It is y equals negative 1/3 x squared. Now, once again, we need to solve that for the squared variable. So this is going to give me x squared equals negative 3y. Okay, x squared equals negative 3y. Now, this is going to be an up or down parabola, right? Because it's x squared. And in this case, because the 3 is negative, it's actually going to be a down-facing parabola. So remember, our basic form for these is x squared equals 4py. So that means that 4p equals negative 3. So p is negative 3/4. So again, if 0, 0, my origin is my vertex of my parabola, okay, and I know it's going down, here's my focus. My focus is going to be 0, negative 3/4, because remember your focus is always inside the bowl, if you will, of your parabola. Okay, your directrix then is a horizontal line, so that's y equals positive 3/4. Remember, it's the opposite sign, so not quite to 1. So positive 3/4. Okay. And then your axis of symmetry, of course, is going to be your x-axis. Oh, sorry. I said x, I meant y. Your axis of symmetry is your y-axis or the line x equals 0. Okay. And then again, if we plot some points here, okay, let me just make a little table up here. Obviously 0, 0. If I put in a 1 for x, I'm going to get a negative 1/3 for y. If I put in a 2 for x, I'm going to get a negative 4/3 y. If I put in a 3 for x, I'm going to get a negative 3y. Okay, does that make sense? Because 3 squared is 9, divided by 3 is 3, but it's negative. Okay, so, and again, I'm going to have points on either side because mirror image. So 1, negative 1/3, and its mirror image. 2, negative 4/3. Again, whoops, I did that down too far. Negative 4/3, just past negative 1. Okay, 3, negative 3. So here, I'm calling that good. Here's my parabola. Okay, something like that. And again, let me remind you, the whole reason this works is that any point on a parabola is equidistant distance to the focus and to the directrix. These are the same. That's how parabolas work. Okay, that's where the focus is. Okay, let's go back and do some of these other, write the equation. Write the standard form of the equation of the parabola with vertex 0, 0 and the given directrix or focus. So if my focus is 1, 0, okay, that means that my P is 1, okay? And if my focus is 1, 0, okay, that is on the x-axis, okay? If your focus is on the x-axis, then that means it's a left or right, right? That's what that means. It's a left or right. So that's a y squared. So this is y squared equals 4px. So if I put 1 in for p, then y squared equals 4x. That's my equation. Okay. I hope you all understood that. Number 6. Again, here my p equals 2. But think about where the point 0, 2 is. 0, 2 is on the y-axis, so that means it's an up or down parabola. Okay, if it's an up or down, that means it's x squared equals 4py. Well, if my p is 2, then x squared equals 8y. Okay, so to me, I'm always asking myself, up or down, left or right? Up or down is x squared, left or right is y squared. Directrix, x equals 3. So this is telling me then that my p is negative 3, because remember your directrix is always negative p. So my p is negative 3, but what I have to think about is what kind of parabola is this? If my directrix is x equals 3, x equals 3 is a vertical line, okay? So that means my parabola is left or right, okay? This is a left or right parabola. So that means that y squared equals 4px, or in this case, y squared equals negative 12x. I hope that makes sense to you. Okay, now directrix equals, or y equals 3. Again, y equals 3 is horizontal. So horizontal, first of all, let me say that that means my p is negative 3 again. Okay, but this is up or down. Okay, if my directrix is horizontal, that means that my bowl, my parabolic bowl or my parabola points up or down, either above it or below it. Okay, so that up or down is x squared equals 4py. So in this case, x squared equals negative 12y. Okay. All right. I think I'm going to move on. I'm going to skip the word problem for now. This is running long. That's okay. But I'm going to skip that for now and let's do practice A. Practice A, just going to do a couple of these with you. So 1, 2, and 3, just match the equation with its graph. Again, if I were having you turn these in, I would say no spaghetti lines. But match the equation with its graph. X squared means it's pointing up or down. It depends on whether the number in front of the y is positive or negative. Okay, I think I'm giving way too many hints here. And then y squared parabolas point left or right. If the number in front of the x is positive, it points right. If the number in front of the x is negative, it points left. I think I'm going to leave that alone. Okay, next section. Tell whether the parabola opens up, down, left, or right. So again, let's do 5 and 6 here. 5, it's x squared. X squared is up or down. But because this is negative, it's going to be down. Now, 6 is y squared, which is going to be left or right. So left or right, but again, if it's negative, that means it's going to be left. Okay, I hope I said that enough. So on this one, this is down. Maybe I should go back because p is going to be less than 0. On this one, this is left because p is going to be less than 0. Okay. Now, graph the equation, identify the focus and directrix of the parabola. I'm just going to kind of quickly, we did 4 of these on the study guide, so I'm not going to spend a whole lot of time. But on number 7 here, x squared equals 4y. So that means that 4p equals 4. So p is 1. So that means x squared, okay, this is going to be an open up because the 4 is positive. So that means this is my focus. So my focus is going to be 0, 1. My directrix is going to be horizontal line, okay, y equals negative 1, okay, and then you got to plot some points. So if you make a little XY chart, okay, obviously we have 0, 0, 2, 1, 4, 4. So you all can do that. This would be like y equals 1/4 x squared, okay. And then, so this would be what my parabola looks like, okay. Hope that's helpful. Next one, write the standard form of the equation of the parabola with the given focus and vertex at 0, 0. Now, this is given focus. So this tells me that my P is 1. But now again, that focus of 1, 0 is on the x-axis. Since the focus is on the x-axis, that means it's a left or right. Okay, so that is y squared equals 4px, or in this case, y squared equals 4x. Okay, now number 13. This tells me that my p is -4. Okay, but think about where your focus is. Your focus is on the y-axis. It's down 4. So that means for it to be in the center of a parabola, that parabola has to open down. That's an x squared. So this is an x squared equals 4py, or in this case, x squared equals -16y, because I plugged in -4 for p, right? Okay, now 16 through 21, write the standard form of the equation of the parabola with the given directrix and vertex at 0, 0. Now, if your directrix is x equals 2, that means your p is -2. Okay, remember your p is opposite the directrix number. Now, if your p is -2, think about what an x equals 2 is. That is a vertical line. Okay, if your directrix is a vertical line, that means your parabola is pointing left or right. Okay, so this is y squared equals 4px, or in our case, y squared equals -8x. Okay, let's do the one beside it. If y squared equals -1, that means your p is +1. Now, y squared, or sorry, y equal -1 is a horizontal line, okay, below the x-axis. So a horizontal line means that our parabola is going to be pointing up. So that's an x squared. So this is x squared equals 4py, or in this case, x squared equals 4y, because our p is +1. Remember, your p is opposite sign of your directrix number. Okay, hope that helps. Now, this one, I just want to kind of draw a pretty picture for you, if you will. They're talking about a sailboat race includes a turnaround point. It's, I mean, they started somewhere out in the ocean. But this, let's say, is our shore. Okay, this is our buoy. Okay, and the sailboats are supposed to come in here and go halfway between the buoy and keep going. Okay, now halfway between the buoy and the shore. This whole distance, they told us, from here to here was 60. Well, what that means is that half is 30 and this half is 30, right? Because those are always, so imagine this, and boy, my picture doesn't really look like it. Looks like my vertex should be over here. I apologize for my bad parabola. But imagine this is your vertex at 0, 0. Okay, well, what does this tell me then? This tells me essentially that my p is 30. That's my hint to you, okay, to finish it off. So my p is 30. So imagine that, again, this is the point 0, 0. Okay, that's your origin right here. Okay, all right. I am done. This concludes section 8.2. Again, we skipped 8.1 on purpose. And if you have any questions, you'll have to let me know.